it was a pleasure having you, sir, in the morning for this, the inauguration of the initiative. And it would be very nice for the audience in general if we can have your views on the initiative, as well as how you your thoughts on how we can take this initiative forward, and what should be expected from this entire team, as well as how we should kind of make it more enjoyable for the audience, for the public also. So
I think YSS Lab initiative is a very unique one. Globally, such initiative exists where the scientists communicate to the mass and public. I think this is very commendable. I'm very proud that the microbiology students of Pune has taken this initiative. I think when young people take initiative, they don't fail. And it is our faith in young people, which I have believed all the time, is that makes a difference. So when youth gets in mass communication, they have a tremendous power. Today with the social media, you can make a big difference. So therefore, I think reaching to the public, reaching to the press, having continuous dialogue and communication to make people aware what you are working on, what you want to give to them, I think is a very important component. I definitely congratulate the YSS Lab for this wonderful initiative. Coming to how you take it forward, I will say that you please use extensive social media, and that will reach to one class of people, and then use local vernacular language based press. And press is very powerful, so you should have meeting with them, explain them in simple terms, prepare notes for them so that they don't make scientific mistakes, and identify people who will actually, those press who will take the champion. Press is always hungry for new stories. So therefore you have to come up with stories, like I mentioned about yo-yo effect, obesity and this. This is very interesting for the people. Then you can think of how microbiota or microbiomes has an effect on elderlies and how they can work on. So therefore there are many, many aspects of this, because I personally believe with the discovery of large influence of the bacteria that we carry, it's a very, very path-breaking, and it's a great opportunity for microbiology students to get attracted and interested. I think you have taken the right steps already. All the things that you have thought of are very, very good. And creating more YouTube's items, so that short videos, so that nobody has to see videos of the Western YouTubes, but I would love to see wonders of microbes are made by the students and for the people, and they can be taken forward. The outreach of getting involved patients and the parents of the patients will be very important. You have to realize we try many things to do professionally, but I believe a movement is best served when there is an emotional engagement. I can mention you that open source drug discovery, when we initiated, the students came up and wrote a poem and song on OSD. And that song got translated from Malayalam to Kannada to English, Hindi and all languages. And this was initiative of students from Kerala. And it had a wonder effect. We came up with the Stop TB program, Need for New Drug. We gave a challenge. Students, instead of creating ourselves videos and things, we asked students. See, everybody is today can be a film director with a cell phone. You don't need even expensive digital devices. Then you will be surprised, we have 1,000 entries. And we had to select 3, but finally we selected 7. And Amol Palekarji himself came and gave the prizes. So I have seen the power of youth in creative way of telling stories. And I think just enlist them, and that's what is required. And you have all the tools. You have a great teacher who will take you forward. So therefore, it's not that because he was my student, but I'm just saying why Yogesh Shauche is an outstanding teacher and is a student-friendly teacher. And therefore, under his leadership, I have no doubt that YSS Lab can take it forward. So this is one aspect of your activities that you are doing, and increasing the reach, outreach.
Yes.
The second aspect, that who is actually your customer? Your customer is people who get affected. Let's say, for example, if you make people understand that you get TB, then how do you make them have compliance? How do you make sure that they take the medicine? What is the need of the medicine? Making them understand that just because the titer of the bug has come down, you are feeling better, but doesn't mean it's gone. And this is the message, if you can reach. Government is unable to reach that message through the DOT program. And I believe 1 million kids in this country, young people, can actually make it happen, which Indian Council of Medical Research or anybody, Health Ministry, cannot solve. Power of the students, power of the youth is fantastic. And present government has great hope of this youth to take action. The next challenge is, how do you find who are at risk for a disease? Construction workers, miners, police personnel who are in the traffic, they are immunocompromised. That because their macrophages takes away carbon particles. So macrophages don't work anymore, and therefore they get the infection. So therefore your next challenge is to at-risk population. How do you reach them? How do you make sure that your message that you need to have a test? If you have these symptoms, this bacteria is working on it. And I'm sure if your outreach takes a focused approach, take up especially the disease like TB, and say, we will make it TB free. Country wants to make it TB free. How do you go about it? How do you fulfill the 2030 Sustainable Development Goal of the United Nations fulfilled? I think you have to show an outcome. You have to measure what you do and see that what you are doing is actually implemented. You can spend your time making video, movies, this, and you feel it goes into your biodata will not help. You have to see that your effort has actually made a difference. And that measurement stick you should be able to do. If you can demonstrate that the construction workers of Maharashtra, the slums of Bombay, people are going for tests voluntarily because you have sensitized them that you are at risk. So you have a whole list of risk workers, and reaching them is the real customer.
That will be a real
and that's where you will be able to make a difference. And then YSS Lab's initiative will be a globally complemented initiative. We have the human genome sequence annotation and all goes on. We have only done a little thing, one TB microbacterium annotation, and you realize that it needed 50,000 papers to be read and hundreds of students to be involved. What is our next challenge? Our next challenge that we got landed up with a large population of that bacteria. There are discussions, 160 or whatever it is, there are bacteria. But we know which are the most prominent ones. Which are the ones now we know actually makes a difference. And you are all experts in microbiology, so you can easily figure it out. The question is, these genome sequences are happening. And genome sequence of a bacteria is child's play now. So therefore, but the challenge is not sequencing, challenge is annotating. So can we annotate, can we take a program involving hundreds of students who will actually do computational annotation? Once you do this computational annotation, that is really you can do by crowdsourcing. I think students are bored of doing classroom learning. And I personally believe the role of a teacher is completely changed. Today you can Google and find out. You don't have to be a microbiologist to know what is one bacteria is doing or what it does. It belongs to which class or all. Even I don't know many of them. So therefore, leave it to Google, right? Classroom goes to Google. What is that important that students gets engaged, what I call socially useful projects. I call social action projects. These social action projects excite students. I can tell you at my old institute at IGIB, we introduced a program through one of my younger colleagues, Brahmachari, where students actually did a newly sequenced genome annotation as a classroom. And this classroom then can be published. So therefore, if we can engage thousands of students through what initiative of like Association of Microbiology students, whatever it is. So therefore, whole challenge is, can we create a set of population of bacteria whom we annotate first? Then we get the pathways. We understand what metabolites it consumes and how it does. And then look them at together, right? And then starts creating what environment, what metabolites pushes a competition between one set of bacteria with the other. How nutrients are picked up. You say this bacteria needs this nutrient, whereas this bacteria needs another carbon source. Then you can control the carbon source and say, I will push this by the bacteria. Then the experimental challenge will be to create a medium which is equivalent to gut. Okay? So that you allow some of this unculturable bacteria starts growing. Our genome sequencing is very easy. We can get from gut. We can therefore, how you go? You go, I would say, reverse engineering. We go for the patient, take 100 obese patient, take the gut bacteria, take 100 lean people, take the gut bacteria, see how is the population changing. Then take people who are pre-diabetic, right? And people who are fully diabetic. And then you have their gut bacteria. So you already have large data sets coming up. It's there. It's a lot of data has come in the world. So once you have identified the bacteria, you know the sequence of those bacteria, then the next challenge is annotate them, find the pathways, see which metabolites they use, and how you can actually then create. So what you need is the students with IT capability. So the microbiology has to now marry with the IT people, and I think it's a very interesting if you can bring computer science students who will be able to get this going. Then bioinformatics students from Pune University, you bring them in, and you should be able to then build the story. And all you need is an open platform where everybody can contribute. And we have already built that for SysBorg, for TB, system biology for organism. So adopt it and take it forward. So while eventually after you have got several key bacteria, which actually whose population goes up in a disease condition and which population goes up in a healthy condition, then you are actually started playing with that. Then you say, how do I do a flux balance analysis by which I can push one set of bacteria over the other? Once you can get the metabolite, then come back to your plant medicine people, and see what plant produces those metabolites, right? Then you can say, hey, this food has this advantage. Then you can create, if you are able to create a culture, then you will be able to experiment and say, this polyphenol will push this bacteria in this direction. And if I put this antibiotic, then selectively gram positive or gram negative goes down, and then I can create the population. Now, I do not believe that they will be high-end antibiotic, because you don't want to kill them. You want to just decrease the population. So there should be a low-dose effect. Then the target would be, you get involved the chemist and say, tell me which drug antibiotic which can be used to kill selectively this bacterial wall synthesis, but not this bacteria. So like that, it's a game, right? So you actually engage students in a game. So it's a game lab. And in the process, when you do game, you actually learn it in the process, completely learn. So the whole entire microbiology course will get redundant, because you are now able to bring them into playing a game.
Right.
And while playing a game, they actually become knowledgeable and they start thinking how to adjust, how to do. They ask me whether by doing this a student will get higher marks. I don't think so. But student will be more valuable to industry than anywhere before. And his career will have far more value. And I can tell today those students who has participated, undergraduate students today, I think we got a data from 92 people out of those 100 odd. They're all top universities and institutions and companies they're working. All their biodata is, they show that the website that this is their name against name. So you have to give micro-attribution. Right? 70% of our data has been taken out by Broad Institute into their database. And we insisted that every student who has contributed, their name has to be there in the database. If you go to the TB database in Broad Institute, you will see 70% is Indian students whose name is there. And with that, the student gets a good reference and say, hey, I'm good at it. Nobody has to show you that how much marks you got. You said, I've solved this problem. I've understood this. And one of the students who did the metabolic pathway analysis, he was not even getting admission to Indian Institute of Science. Today he is in Stanford. And that's possible. So it is what I call social engagement approach. You get emotionally engaged and science becomes more interesting. So I'll say this is a new way. Nobody really knows how to go about it. That's why I say young people will figure it out how to go about it. I don't think I sat and decided how genome to be annotated. It was all 25, 26 years kids. They decided how to do annotation. My job was, I want this annotation, right? So you create a demand. And so today I created a demand for you. That I want to see that you come back with large amount of microbiota annotation and let world notice it. That you are the one who is doing it. And then others will write stories of it.
I just want to touch upon one small aspect about the mimicking the gut environment. Especially when you mentioned the game part, this just crossed my mind that what about we know that the bacteria cannot think on their own, but we do know that there are a lot of social interactions which play a part, and it can be called as a social memory. I'm just speculating that how can we mimic that, because if we have to put that aspect also into this particular
so you see what? When you say social interaction, how do the two bacteria interact? They send some chemicals out.
Yes.
Right? If I produce something that you need, you will be a friend of mine.
Right.
You come close to me because you want to capture that what I produce. So each bacteria, you think about, I have a cow and I get milk. So you want to drink milk, you will become close, collect the milk. So any product that one bacteria is producing benefits another bacteria, they become social bonding, right? And any product that is toxic to the next bacteria, he goes away. He doesn't want, chemotactic process, he will go away. So your job will be to figure it out. And that's the challenge. And why I said game? Because you see today, brain mapping, every neuron mapping is taking, they were doing very slow. They were doing 1 or 2 neuron mapping in a day or two. Now they're doing 8 to 10. What did they do? They developed a game. And they asked students to play the game. So students are playing the game. When students play the game, more annotation is taking place of the brain neurons. You have to remember, there are millions of neurons that you have to do. So therefore you have to involve hundreds of students to do. So this is how I believe that tomorrow's science, we have done classical way of doing science. So science 2.0 is different, right? Our education has gone through various stages. We had Gurukula system.
Yes.
Then we had mass communication, right? When universities, colleges, when teachers tells you. The education 3.0 or 3.1, because 3.0 is going to be social media through self-learning. It's self-learning. So people will learn a new way. And that's what the opportunity this particular system gives you. Because any system where you want a large crowdsourcing, that should be able to break up in a small pieces. Right? And this is a perfect system where each component can be broken down and people can work on it. So therefore, I will say, you can make a competition and say, I want to see, can you discover a gene that is there in this bacteria is not in that bacteria? So there are competitions, there are games you can play. And I think the YSS Lab should create this initiative.
So when we talk about this ambitious project as you have enlightened us, so this needs to bring a lot of students from different streams to come at a single forum. And when we have to do this, we have to kind of do a interdisciplinary research. And that's, I think, is a big problem in few of the reasons.
Yeah, that's what I say. See, if I had to build an institute, which would have done OSDP, I would have never been able to do it. Right? But cyberspace, we have students participating from Pakistan. He did a visa. Right? It's in cyberspace. Facebook, social media, everybody is connected. Everybody can participate with everybody. So therefore, you need a digital platform. You do not think the laboratory of microbiology is frozen in space in Pune city. It is in cyberspace. It is an ether network. And anybody can come in and participate. So it's a social network engagement. It's a commitment. Lives in it blindly, takes it forward and executes it. And the moment there are two people, see, the leadership is often maverick. It's very difficult to copy. But when the leader gets to disciple, who can copy it, takes the view and simplifies it, then the crowd gathers around those who copy, not around the leader. The followers. The first follower and the second follower are the most important. So I can give you an idea, but it depends who takes up, who takes it up, and who is the first follower. And the first follower attracts the second follower. And when the third follower comes, see, it's a crowd, right? And then it happens. Then the other starts thinking, hey, I'm not joining, I'm falling behind. So I join. That's how all the students have a Facebook page. When there was no Facebook, nobody did it. But I'm falling behind, so I join in. So that's how you join in.